Hi, this is an introductory session on solving B.Stat and B.Math question papers. Now, this is kind of an exercise which will be beneficial for people preparing for any kind of an ISI exam or any exam which has mathematics content in it. So, it's highly beneficial for people who are preparing for JEE or for MSQE or MSQMS or any other master's courses which has maths component into it. And also this will not be beneficial to people who are preparing for CAT, because a lot of the questions which we'll be discussing will be of the JEE level. So yes, this will be also relevant for people who are preparing for the PGDBA exams, the Tri-Institute exam by ISI, IIT and IIM. So let's just start solving few questions, and then we will see how many sessions we can have. But yes, this is the first introductory session and this will be of a brief length. I'll just start solving, and then I'll see its response in few days, and then we will see how frequent we can continue this session. So I'll just post the link of the question paper which I'm starting to solve on the chat, and I'll pin it, and then we can be on the same page. So I have posted the link of the question paper on the chat, so you guys can have a look from there. So now let me just look at the question paper and start solving, right? So let me share the screen as well. Okay. So if I look at the first question, you can see question number 1. Question number 1, the number of subsets of this set 1 to 10 having an odd number of elements is. So this is a pretty standard question which is asked in a lot of exams, and this can come even in a CAT exam. So this first question is for a very wide audience. This is applicable for any exam which is maths in it. So let's first write the set, which is a set over here. So we have 1, 2, 3 and so on till 10. Now I need to have a subset, rather I need to collect all the subsets which have an odd number of elements, right? So as of now, this set, let me denote it by capital S. The number of elements in this subset is equal to 10, right? So if I have 1, it's okay. If I have 3, it's okay. If I have 5, it's okay. Till 9. So which is not okay for us? 2, 4, 6, 8. These are not okay for us. So let us say if I find all the sets satisfying this condition, number of elements is 2, 4, 6, 8, because that's what they are saying, having an odd number of elements. So I'll just take the inverse of that, even number. So this will give you n s e, and if I construct subsets by this, then I'll have n s odd. Okay, I missed one here in the even thing. Also 10. And let's try to understand that how can we find this out in a quick way, because over here we have just 10 elements in here, so we can directly count it very quickly, but we need to have some kind of a scalable way to do it. So let me just think about it. So if we are choosing 2 from here, okay, the only way which I can think which is scalable in nature is this thing. So if I just have directly count out the odd ones, it will be n choose 1 plus n. No, I should not write n, I should write 10 over here. Yeah, 10 choose 1 plus 10 choose 3 and so on till 10 choose 9. So we can calculate it through this way, but the thing is, this is not scalable in nature, because we'll have to, if let's say I give you 100 elements, let's say ns is not 10, ns is something like this, 1000. So what will you do in that case? You will not calculate this, right? Or rather you can also calculate it, but we'll have to do some kind of simplification on this. So this is something which we need to look at. So I will be parking this question as of now, and I will be focusing on this question in a future video or in a future session, that let's try to find out a shortcut to calculate this binomial series, right? Now let's just move on to the next question. The next question is, for the function on the real line given by this, fx is mod x plus mod of x plus 1 plus e to the power x, which of the following is true? And I need to check the differentiability. So if I can look at it, there's a mod function over here, right? Let me just magnify the question paper. The moment you see a mod, you should think about where is the function changing. This is changing at 0 and this is changing at 1, right? And this is a pretty standard smooth function. So let's just write the definition of the function properly in the different ranges, rather in the different domains which we have. So let me just do that on the whiteboard. So what we have is fx is going to be, if I take x less than 0, this quantity will be negative, so I'll have to use a minus. Even this will be, no, this will not be negative. This will be negative if x is less than minus 1. So let's try to have minus 1 the first criteria, as x less than minus 1. So if x is less than minus 1, this is negative and this is negative, and this is our pretty standard, nothing more here. So for x minus 1, so the first is minus x plus e to the power x, and this is when your x is less than minus 1, right? Let's look at this. Yeah, minus x minus of x plus 1. Yeah, because I'm in the negative territory for these two things. Now what about if I am in x which is greater than equal to minus 1 but less than 0? So if this is the condition, you can understand that the first term which you have over here, this is going to be negative, but this is going to be positive, right? So you can safely write minus x plus x plus 1 plus ex. 1 second. Now comes the last case, when let's say your x is greater than equal to 0. In that case, this will be positive, this will be positive. So it will be simply so if I have to look at the function this is your 0, this is your minus 1. So if I'm greater than equal to 0, I'm simply x plus 1 plus ex, so it's 2x plus ex plus 1. And if I am in this range from minus 1 to 0, this x will be cancelled out and I'll be left out with ex plus 1. And if I'm in this range less than minus 1, we will have minus 2x plus ex and minus 1. This will be minus 2x plus ex minus 1. So these are three ranges which we have. Let's just first look at the continuity case. I mean, how is it doing over here? If we put x equal to 0 over here in this part, this will be your 0, this will be 1. So 1 plus 1 is 2, and same goes for here 2. So it's continuous at 0, that's pretty sure. Now what about this? Put x equal to 0 here, put x equal to 0 here. You will have 0 here and 1 minus 1, which is 0. And what about over here? If you, not 0, I had to put minus 1 over here, my bad. So if I put a minus 1 over here, what I will have is e to the power minus 1, and this will be your 2 minus 1. So 1, this is 2, minus 1 to minus is 2, so 2 minus 1 is 1. So I have e to the power minus 1 plus 1, the same, e to the power minus 1 plus 1. So continuous over here as well. Now how would I check the differentiability? Now a very standard way to think over here is, because as I have a very polynomial kind of or an exponential kind of a shape, let's just directly differentiate it in the piecewise regions, and then we will automatically understand if it's differentiable or not. So if I differentiate over here, I'll have minus 2 plus ex. So let me write it as ex minus 2. Over here I will have simply your ex, and over here I'll have your ex plus 2. So if you look at the differentiability condition at this guy minus 1, to the left you will have e to the power minus 1 minus 2, and over the right you will have e to the power minus 1. So definitely this is some kind of an issue over here of differentiability. What about 0? If you check at 0, it will be e to the power 0 1, and if I go to the right, e to the power 0 1 plus 2 3. So again I have an issue over here. So both at minus 1 and 0 we have issue. And what about the other parts? Now this is a pretty simple thing. It's differentiable, this is differentiable, this is differentiable. And if you add all the differentiable functions, you will have differentiability, right, met. Same goes for here, same goes for here. So just leaving out minus 1 and 0, for rest of the points you will have a differentiable function. So that is what you can see about it. It is differentiable everywhere except at x equal to 0 and x equal to minus 1, right? So 2b must be the answer for this. Now before we move ahead, let me look at the chat to see if we have few people asking some questions. Okay, we have no one asking any questions, so we will continue this discussion. The reason I'm doing this is because a lot of people in my comment section keep on saying that they need some kind of a video on B.Stat B.Math preparation. So I never prepared for B.Stat or B.Math, but what I have understood is that most of the preparation of B.Stat B.Math is similar to your JEE or Olympiad level maths preparation, and I feel that I have some kind of background on that, so I will cover those things in some way or the other, not very extensive way, but I have started taking baby steps in the B.Stat B.Math category as well. So let me look at the next question, and let me share the screen as well. The next question says that you have FG real valued differentiable functions on the real line R such that f of g is x and f dash x is 1 plus fx whole square. And what is your g dash x? Okay, uh, let's try to solve this. I know f of gx is equal to x, and f dash x is given as now you need g dash x. Let's first differentiate this, right? So you will have f dash, sorry, f dash gx, then chain rule, g dash x is equal to 1, and I know that f dash x has this form, so I can write it over here like 1 plus f of gx whole square or you can write it in this way as well. So this is our answer, and we'll have to find a way to match it with options. What are the options which we have? We have all in terms of x, so we have to remove our f of g kind of a thing. We know that f of g is x, right? So let me just plug it over here. So this will change to I'll write it like this, 1 by 1 plus x square. So if I look at the options, this is 3a. So this is the answer for the third question, 3a. We directly did the differentiation and nothing else. So you see, B.Stat B.Math questions are not really rocket science questions. Those are pretty standard questions. If you are thorough with your concepts, you would not have difficulty. But as of I remember that even B.Stat B.Math has a lot of competition like your other exams. So you need some kind of speed advantage here as well. So let me just look at the few chat questions if we have any. Uh, Varun is saying through this we get a more clear idea of how and what exactly is required in this exam. Yes, Varun, you are right. Okay, let me share the screen again and then we will solve the next question. Okay, then next question is you need a number of real roots, or rather real, not real roots, real solutions of this equation. So this looks a prime candidate for a graphical solution. So I will not solve this because this is something which I feel that you guys can easily solve it. So let me just point you towards the direction. So what is the equation? Let me write it. I have Ex and I have sin x. I just need to find out where they are intersecting, right? And number of real solutions. So think about it. If you draw the graph of Ex, it will be something like this. This is your 1, right? So let me just do a dotted 1. And I know that our sin x can never cross 1 in the positive side, and obviously ex will always be on the positive side. So if I just draw it, it will be something like this, and this will be something like this, right? So now you have to find out the number of solutions. So it would require a bit of thinking, graphically as well as analytically. So I will let you guys do this. Now I'll move to the next question, which is limit question, and we have a summation and n tends to infinity. So I hope you guys got how to solve this question. So I'll just take out this and we'll move to the next question. So it is summation k from 1 to n. We have summation k equal to 1 to n, and inside we have e to the power minus k by n upon n. Yeah. So if I look at this in a different way, it's 1 by 1 into e to the power 1 by n sorry, this is n, and so on till 1 by n e to the power n by n. Let me take n common from here. Okay, so we can directly sum it, because what's happening over here is that this is kind of a GP with a common ratio of what is this thing? Yeah, with a common ratio of 1 by e to the power 1 by n, and the first term which we have is this thing, the same guy. This is also our first term. So if I do the next calculation, I will be landed with a 1 by n power n power 1 by n. Okay, so now we need to just use this green thing. We'll erase the other parts, right? So let me just erase the other parts. Rather, I'll just do this in a different board. That makes more sense rather than erasing it out. Duplicate. Okay, So this is what we have over here. And inside, if I take an nth power, this thing will be gone, right? So it will be our simply e. So this will be 1 by e, right? Let me just check it again. Yeah, this is right. Now I need to find its limit when n tends to infinity. So if n tends to infinity, let me try to simplify it further. This will be okay. So we will have okay. So I've just directly multiplied e to the power 1 by n to the denominator as well as the numerator. Now what we can do next is let's try to think the form of this. If I put n equal to infinity, this will be your e to the power 1 by infinity or e to the power 0, which is 1. So 1 minus 1 is 0. This will be infinity into 0, or we can write it in this way. Yeah, let's write it in this way. This will be your okay. So over here you can say that this is your 1 minus 1, which is 0. 1 by 0 is infinity. This is infinity by infinity form. So you can, let me just make another board to accommodate this. Duplicate. So what we can do now is, let's just take out this guy common, this constant thing. So we will have 1 by e, and then we will have yeah, we'll have 1 by 1 minus e to the power 1 by n divided by n. Yeah. Okay. So I have to find the limit for this guy first, right? And I know that this is of the form infinity by infinity. So I can use L'Hopital here, right? So let's try to use L'Hopital in the thing over here. So if I differentiate the upper guy, rather denominator, I'll have just 1. What about the upper guy? For the upper guy, what I'll have is, uh, it's simply your minus 1 will come outside. Then inside, if I check, we'll have a minus of e to the power 1 by n, and then chain rule, which is your minus 1 by n square. Okay, so this means that I will have e to the power 1 by n. There's a negative sign over here as well. Let me write over here. So again I have this is my, okay, so this is going to be 1 by 0, this is 1. Okay, this will tend towards 1, 1 by infinity 0. This will be 1 by infinity is 0, so e to the power 0 is 1. So 1 minus 1 is 0. So this is 0 into 1, which is something like 0. 0 by infinity, 0 by infinity, this is becoming form of 0 by infinity, right? So 0 by infinity is this determinate. We can say that this means 0, right? Which means that the limit is actually 0. Or rather we can say that limit does not exist, but I'll have to recheck the calculation over here. Okay, so this is also a question which I'll have to recheck what I have done and reconfirm with you on the solution for this. So I'll be again parking this question for future sessions, and let me just take one final board. Yeah, and let's look at the next question. And before I move to the next question, let me just look at the chat for a while. Yatharth, hi Yatharth, I'm doing great. Thank you, Masood. Now let's look at the next few questions which we have. This is a PNC question. A group of 64 players in a chess tournament needs to be divided into 32 groups of 2 players each. It's a pretty standard PNC question, so I mean no point in solving this question now. Then the integral part of this equals, integral part meaning, let me just give you the theory part of this and you do the solving, right? So what is integral part meaning? I mean, this is not that difficult an integral part concept. What you have to remember is every number, let's say I have a number x, so x will have an integral part, so I can denote it by a box function, greatest integer function, and this will also have a fractional part, right? This is my fractional function. So this is your I integral part and this is your f or fractional part. So if I have to give you what is the integral part, it says that let's say your number is 2.6, so integral part will become 2. If your number is 3, integral part will be 3. If your number is minus 2.1, your integral part will be minus 3. Yeah. So because I have to just take the number which is smaller than this number or equal to this number, but it is an integer. What the fractional part? For fractional, this is 0.6. This is 0. And for this, the fractional part will be 0.9, because if I add 0.9 with this number, I'll have a minus 2.1. So you see, fractional part is always between your 0 which is included less than 1. Fractional part can never be equal to 1, but it can be 0. But it is always positive, that is or 0. That is what you have to remember. So in this question, what they are saying is that what is the integral part of this? They have given you a sum, right? And now you just have to do the sum and then tell them the integral part. So integral part is essentially this thing, your greatest integer function. So obviously you'll have to do a bit of calculations, which I'm avoiding as of now. Now the next question is number of subsets that do not contain any two consecutive numbers. So I'll just give you the hint over here that you have n numbers, and if an is like the number of subsets that do not contain any two consecutive numbers, then an means that, let's say you have 10 numbers, so a10 is the number of subsets of 1 2 3 and so on till 10 that do not contain any two consecutive numbers. So in that way you have to do an minus 1 and an minus 2, and there's some kind of relation between them. You have just to find that thing out, right? So I'll also be skipping this question. It's not that difficult to solve, because over here I'm just trying to look at few new type of questions which will be a value addition. So again you have a circular permutation question which there's no value add as of now. Yeah. Now you have a complex Z and W be complex numbers lying on the circles of radii 2 and 3 respectively with center 0, 0. If the angle between the corresponding vectors is 60 degrees, then what is the value of this quantity? Now this is a very important question and I will cover this in a video, right? So I'm kind of noting it down somewhere. Maybe I'll just note it. Let me duplicate this whiteboard and note it in that. Okay. So over here, question number 10 is something which I can wait to look at. Then you have two vertices of a square lie on circle of radius r, and the other two vertices lie on a tangent to this circle. Then the length of the side of the square is, now this is an important question because this is applicable to a lot of exams, PGDBA, CAT, MSQE, JE, now a lot actually. So let's just think about it. You have a circle of radius r. So let me just reload. Okay, and then you have two vertices lie on tangent and two vertices lie on a circle. Let's just think about it this way. No, first draw tangent. Okay, you get the drift, right? This is like a point over here, and this is your small r. This is also small r. Again small r. Now what else we can do? How to find out the edge length? So this is your 90 degree, right? Okay, and this looks a pretty symmetrical situation, so I can safely say this is a by 2 a by 2, and this is your a. Hmm. And this is also your a. Okay, I did a mistake over here. This is not r. This quantity is not r. This is r. This is something which we do not know as of now. But yes, what we can say is this is a by 2. This is parallel. So this is a by 2. Okay. Now this guy over here has to be r. Now this is a by 2 and this is r. So you can find this thing out. This is nothing but square root of square. Okay. Now I have found out this length, and this length we know is r. So if I add r to this, I must get a, and I need to find a. I know r. So what we can do is root of is equal to a minus r. Now over here, this is a classic equation which we have found out. If you square this, you will get r square minus a square by 4 is equal to a square plus r square minus 2ar. Now from here you can get the value of a in terms of r. Now there could be smarter ways to solve this question, so I will leave that as an exercise for you to find smarter ways. Let's look at the next question. So the next question is about greatest integer function, the integral part which I was saying in the previous one or two questions back. So for any real number x, let this denote the GIF, or your greatest integer function, or simply the integral part. The number of solutions to this is, okay, let's look at this. It's a very interesting question. So let me just reload this. Yeah. So over here we have mod of 2x minus box or GIF or integral part of x mod is equal to 4. Okay. So over here, what we can think over here is, if x is a positive integer, right? So let me say if x is I plus positive integer, in that case this will change to 2x minus x mod is equal to 4 or simply mod x is equal to 4, and as x is a positive integer, so x is 4. So here we have one solution over here. What about the other one? So let's say if x is a negative, before moving to negative integer, let's look at the obvious case. If x is 0, put 0 over here, right? You'll get 0. Put 0 over here, you'll get 0. So this is no solution. So I'll get no solution from here. So let's me look at negative integral part. For the negative integral part, what you can think over here is that again for your 2x you will have 2x, but what about the box function of x? For negative integral part you will have to yeah, it will be the same thing, because for the negative integral part also, let's say minus 3, the greatest integer function for this will be minus 3, right? So for this as well you will have the same equation, right? And then it will mean, as x is negative, so minus x has to be your 4, or x is equal to minus 4. So you have one solution from here, x equal to minus 4. Now this we have done considering all the integers, positive, negative and 0. We know that we have two solutions in that case. What about if x is not an integer? Now that is something which we really need to solve for. That what will happen to our this guy over here? How long it will be remaining for if x is not integer? We know that if x is integer, we have two solutions, right? So what we can do is, let's just reload this. We know that for a fact 2 is the minimum answer which we have. We need to have 2 or greater than 2. So before proceeding ahead, a saner thing is just look at the options and then we'll proceed ahead. So we have 1, no, 1 is ruled out because we have 2 at least, we have calculated. Then we have 3 and 4. So we have to solve this. There's no way of escaping the solution for this. Let's reload. So reload. Okay, so we have mod of okay. So let's start the solution part for this. 0, 1. What will be the value of this function between 0 and 1? Between 0 and 1, if we look at the greatest integer function for x, it will be simply 0, right? And 2x is something which will be there. So between 0 and 1, I'll simply have 2x. And obviously if I take a 2x, the maximum which I can get is at your 1, which is like your what will be the value, not 1 but almost near 1, not equal to 1, because at 1 this thing will change, this will be x, so 2x minus x will be your x. So at 1 you will have 1, but just before 1 you will have 2, it will be close to 1 but not close to 2 but not really 2, because x is less than 1. So still it will not touch 4. What about between 1 to 2? If you look at between 1 to 2, the greatest integer function will be your 1 and this is 2x. So this will be your in between, I'll have 2x minus 1. So if you look at the value of the function at 2, it won't be of any use to you because you have already known for integers. So look at the value between 1 and 2. So between 1 and 2, the maximum which I will reach is when x is very close to 2. So that will be 2 2s are 4 minus 1 3. So the maximum it will reach is your 3. See, the maximum it will reach is 2, then it will be 3. Now you definitely know what is the pattern which we are converging towards. Now if we look at between 2 to 3, we can see that this will, the GIF of this will be simply your 2. So this will be, one second, this will be 2x minus 2. So if we look at the maximum for this, it will be close to, it will be near close to 3. So let's say put 3 over here. So 2 3 is a 6 minus to 4. So it will approach 4, but it will never be 4, because at 3 this will change again. It will change from 2x minus 2 to simply your 2x minus 3, because at 3 your GIF is 3, right? So for that case you will have 2 3 is the 6 minus 3 is 3. So over here also I'll have no solution. What about between 3 to 4? This will be your 2x minus 3. And now let's look at this, which is very close to 4. For very close to 4, I'll have 2 4s are 8, 8 minus 3 as your 8 minus 3 is your 5. Okay, this was how much? 2 cross to 4, sorry, 2 cross 3 6 minus 2 was 4. This approached 4. Now this 2 cross 4 8 minus 3, this is approaching 5. And if we just go above 3, 3 2s are 6, and this is minus 3. So between 3 and 4 it will go from 3 to 5, but it will never touch 3, because at 3 what will happen is our box function will be activated. 2 3 is 6 minus 3 will be 3. Okay, 3 will be there, so 3 is included part of it, but 5 is not included. But anyway 4 is in the middle, so there will be a part where I will have 4 as our solution for this thing. So definitely I have one solution between 3 and 4, right? And what about the negative part? So I have done for the negative part. Your exercise is do it for the sorry, I have done for the positive part. You have to do the similar exercise for the negative part, right? And then definitely you will know that what are the number of solutions, 2 3 4 or 1. Now yes, there's a thing which you have to remember. For these kind of questions, generally you do not have closed form solutions. You have to do a bit of hit and trial, or do some kind of piecewise definition of function. So that was all. Let me look at the chat and then we'll proceed ahead if we have to. Bharat is, it needs time. Bharat has a question that when I will do the questions packed for later. Later means later. Later is not a date, right? It could be at any point of time. And this is not the only thing which I do. So definitely later is something which is not having any kind of commitment associated with it. Now Vikas is asking which topics have highest weightage. There is nothing like which has highest weightage. You have to devote good amount of your importance to all topics. Now before we move ahead, let's just look at which question we are at right now. Right now we have solved 12th question, and then in total we have 30 questions. So definitely I cannot finish it today. So I will remember that I have done it till 12. So in this board I'll write done till 12, and I have to cover question number 10 again. And there was one more question which I think I had left out, but yes, I'll do 10 first, because 10 is an important question. So question number 10 and done till 12 of which year? This was of year 2020. Okay, this is your UGA 2020. Okay, so I think I'll not take more questions today. I mean, I'll not rather solve more questions today. I will continue it some other day, maybe tomorrow morning or afternoon or evening. Uh, and then let me see what will we do with these questions. So this was just an introductory session on B.Math question solving, and I will, if I am in a good position to cover how to prepare for B.Math, I will even cover that part of it, right? So do stay tuned and do not forget to subscribe if you're new here and you're interested in something related to B.Math or B.Stat. So if you are someone who is preparing for B.Math or B.Stat, do comment and let me know, and then I'll understand that there is sufficient interest in this kind of an analysis, because majority of the audience of this channel are people who have already completed their undergraduate education, or they are through their almost through their undergraduate education, and they are preparing for master's education. So definitely I want to gauge the interest in this kind of an analysis. And the thing over here is that even if you're preparing for master's exam, the B.Stat B.Math questions are pretty good preparation for you, because B.Stat B.Math questions are almost the same as the JEE questions, and JEE prepares you for all the master's mathematical exams, right? So with this I would open the chat window for general queries. If you have any general queries, I am here for 1 or 2 more minutes, and I'll take 1 or 2 questions, and then I'll end the live stream. So I'll be waiting for your queries. Okay, right now it's 8:30, and at 8:31 I will end the stream if I do not get any query. Okay, so good night guys.